So hi guys, today we are going to look at a very nice problem. Someone who is trying to try a new data structure called Trie. This is a very good problem. I've opened it in this website because this is premium problem and you won't be able to unlock it unless you have premium data code. This is a very straightforward problem in order to understand, but its implementation is very large. But still it's very good problem to learn try for the first time. There are other problems as well which is easier than this one, but this one combines a lot of other things, other data structures as well. We'll look into it. So in the problem we are given a frequency of sentences and we are going to input some characters. So which character, the character we are inputting, uh, we need to return the sentences which matches with the prefix, the first condition, and we need to return the top three ones if it is matching with the prefix. If only two are matching, then the top two one. If only one is matching, then the top one, and if nothing is matching, empty array, right? So here we also need to see that if there are two uh, sentences which have the same frequency, in that case the judgment will be made by the lower uh, ASCII value of the sentence, whichever is the lower ASCII value will be the one that is going to be added in the answer. Right. So here space is also going to be counted. So here space is there in I love lead code, but in Ironman there's no space. So after I, R and space are compared, and the space is having something like 32 or so ASCII code, and R is having 114. So because space is having lesser ASCII code, then that's why I love lead code will be added to the answer instead of Ironman. So that's it. I think since I've already told you that this is a try data structure we have to use. So yeah, I mean initially we are given these many sentences with the frequency. We have to keep track of the frequencies. So a map is required. After that, we are going to use try data structure. So we are going to construct the data structure with the given sentences first, and then again use that try data structure to check, to search, look up if this prefix is present or not. If it is present, then from that prefix we are going to do a DFS and find uh, all the sentences that we can form. Another thing is the try data structures. We are going to have try, and we are going to construct try using these sentences. And whenever we type a character, we are going to look up in that try data structure if it's present or not. If it is present, this prefix, whichever prefix we are at. For example, if we are at here, then I space A is the prefix we are looking for, right? So in every operation, the data structure is going to be persisted. It's given in the question somewhere. So we are not going to worry about if the data structure is going to reset after every operation. No, it's going to reset only when we are going to type hash. So this is when the data structure is going to, I mean, uh, the current string, which was I space A at till this point, is going to be again back to empty string, right? And till this point, whatever the string was, that is I space A, will be added into the frequency. So next time we search after no, hashtag, we are going to also check for I space A if it's matching the prefix or not. So yeah, that's about it. Try data structure to construct with to initialize with these four or whatever sentences that we are provided with. And the last thing is, yeah, so we have to also keep track of the minimum of the two, right? Which is having lesser ASCII value, and the maximum of the given sentences, the maximum frequency of the given sentences. We have to keep track of these two things as well, right? So that can be done using a data structure called priority queue, and we can use min heap and max heap to keep track of uh, or to have only the required sentences. So yeah, let's begin. Uh, I have the basic template here set up. This is the main function, and with the given input as given in the question. This is the object, this is the class, and this is the object. So initially, let's see what are the things that we are going to have. We are going to have a try that we call root. Next thing we are going to have is we are going to create try. Let's see. Uh, the next thing we are going to have is a map, right? And this map will be what? A string, comma, int, right? And we can call it frequency, and then we can have a current string to keep track of what is the current prefix, right? Current string can be another variable, and the next thing we are going to have is a class called try. Here we're going to have, we can use vector, but I'm more comfortable using maps, so I use map. Vector is more efficient in some ways. I'm going to have, this will be character, and this will be a try. This I can call it children, and I'm going to have a boolean called end. This will be the point where my string that we are I'm going to store is going to end. Alright, so constructor, and the constructor I'm going to have probably initializing end to false, right? And yeah, yes, that's it. Yeah. The next thing I'm going to do is initialize root here, and then the root go as try. Yeah, so this will be try, and I think I should make this as public. Yeah, so this is the root, and I will initialize. Yeah, I'll construct. So for construction, I can have a insert function which will take the try root, or I don't even need the root since I'll be using this function for another purpose, right? Or when I will be getting a hashtag. So that's why I'm creating insert and taking root here, and I'm taking a string called boy. if for I traverse the word, each character, so auto character word, if the root contains that the children of that root contains that character, in that case, if it does not contain, then in that case I will create a root, will create a trie, and I will go to the root should be initialized, should be uh, third. Here the root of children. So if it is not present, in that case I'm going to create a trie for that ch. Right? So this root children is going to have a new trie, and I'm going to take root to that trie. Right? And I will at the end, when I've inserted the word, I will change the end boolean to true. So this has completed my insert function. Here I am going to insert and construct, and that will be through sentences. I will also construct the frequency in this loop. So let's do that first. Words and probably sentences. Here I'm going to initialize or all the function insert with root and sentence, and the frequency of that sentence will be increased by 1. So yeah, that's complete. That completes my constructor of this object auto system, of this class autocomplete system. And in the destructor, I will delete the try or delete root, and in the input, I am going to check first if this input character is a hash. If it's a hash, then I'm going to insert the current string, whatever it is as of now. I'm going to call the insert function with root and current string, and I'm going to insert, and I'm going to reset the current string now to empty. So that's how this case will be handled. And if it is not, in that case, I'm going to search. So I'll create a search function. Search function, instead I should call it, yeah, search function is fine. I'm going to call a DFS in this search function if it matches. Then search function is fine and this is going to return something. It's going to return a vector of string, which I'll take it in this variable called search results. Probably all search results, and this will be going inside. Yeah, and search is going to have what? The current string, the root, the current string, and that's probably it. After that, let's see. Let's create the search function first. Like this will return vector of string. This is called search. This is going to have parameter, first parameter as root, second parameter as word, and I'm going to go through the entire word auto ch word, and if this root children contains again the same thing, I'll copy paste it here. If it does contain, then I will take root to that point, right? And I'll have a else condition, else return empty. If it does not contain, and if I have exhausted everything, all the words, in that case, I'm going to do a DFS. So I'll have a function called DFS again. Here I will pass the root because at this point the root is at the point where the prefix has matched, and after that I'll do a DFS, right, to get all the different possible words that we can form with that prefix. So this root is not at its root position, but it is at the point where the prefix has ended, and I'll call word, right. Uh, and also I'll pass probably this. Um, I'll have a vector string here, right. Um, yeah, I can have it here. Search results, and search results I'll call pass it here with reference. I'll pass it so that I'll update this here itself, and this I'll return search results. Now I'll make the DFS function. This will be void DFS. I'll pass the root. I'll pass the string or the prefix, I should call it. I'll pass the search result with reference, which I'm going to update. Right now, I have a base condition where the root has reached a point where the end is true. Then I return. Else, I will traverse the entire root, I mean entire children, right? That will be a function iterator. I'll be iterating through the children, right? Instead, I can also do that. This can iterate through the entire alphabets, and I'll check if this alphabet is present in this. So I have to do something like this is the character, right? I'll do something like this. I guess this should work. And not equal to root of sorry root of children dot end. If this is the case, in that case I will, or if it is equal to end, in that case I'll continue. Else I do a DFS and I will pass in the root again. Now the root will be root of children of I, again, character of I plus this. We can just traverse the map as well. That will be easier to code. I've done it this way. Okay, and this will be the try, and the prefix will be what? Prefix will be the, I should call it string. The current string will be better as just, or prefix is also fine. So I'm changing it to the word, right? That's why I was thinking if I should update the name. Prefix plus, again the same thing, this character. And the search results. Yeah, the search results. Uh, but I've missed one thing. I'm not updating the search results. I'll return it here. I'll update the search results here. Dot push back. Here I'll update the search results with the current prefix. Alright, so this is the DFS. I hope I've not done any syntax error or something. We'll look at it later. Now comes the part where I have to create a priority queue. So I have all the search results in this one, and yeah, I guess I will create a priority queue. Priority queue. Here, the priority queue will be very interesting. So I can have a priority queue of the entire size of all search results. I just keep on adding this again, and I can uh, just keep track of the maximum frequency later, and if the frequency is same, then I will take the minimum one, but that will be, in terms of time complexity, that will be O of n log n, right? Because I'm using all the search results. It can be in worst case everything, but if I only need three, right, so I can do the opposite. If I need maximum, I can take the minimum heap, and I will add only three elements, and then I will add the first three elements, and I will traverse the next element and check if the maximum in a min heap, the minimum frequency will be at the top. So if the frequency of this next word that I encounter is greater than the frequency at the top, then I will replace it. This way I'll have only three variables to keep track of, and that will be the top, at the end, that will be the top three frequency one. And for equal frequency, I can do the same thing in the opposite way. So, so let's see. Int, vector of int, and so sorry, this is not int. I have to keep track of both the things, right? So I can have a pair of int, that will be the first variable, and the next variable will be string. So probably I should keep a type def, that will be better. PLS or PIS. This will be PIS. This will be PIS. This will be a comparator function which I will create, which will be PQ. So comparator function is created outside here, uh, or even outside. I mean outside of this class is fine. Yes, comparator of the operator constant PIS. I should keep that typed as outside. Keep it here, keep it here. Oh, so now this is uh, LHS, PIS, RHS, and if LHS dot false is equal to RHS dot false, in that case I'll do something. I'll do if the frequencies are equal, I need the minimum one, so I'll take a max. So do the opposite, right? This can be a little bit difficult to understand, but if you try to do it and print things, then it will be easy. So I need a max heap. This is the max heap. And here I need a min heap because I need the maximum frequency. The min heap will be this RHS dot force. So this, alright, so I think I'm missing a function here, and this should be first instead of this. Alright, so this is the comparator. I got the from, I can use it in the priority queue. I have already used it. So now I will traverse what? All source results. I'll have a, okay, I'll traverse the variable all source results. I'll get E. I'll see if the current size of PQ is equal to 3. If it is equal, then do something else. I will straight away add what? PQ dot push a pair, that will be either, that will be frequency I'll get it here, and this. The next thing I'm going to do is check if the top element frequency is what? If it's smaller than the frequency that I see in this map, in that case, push, sorry, pop, push, and push will be what? A pair of what? Uh, Again, the same thing. All right. I think I'm missing something here, right? Because I'm inserting, I'll also insert this frequency of current string that I have inserted into the map. So this is done, and here, else if the frequency is equal, this is equal, in that case, check if this the second element, which is the string at the top, is the maximum because I'm taking a max heap, right? Yeah, I'm taking a max heap, so it's the maximum. If I have something smaller, I will take that, and that will be A. If very smaller, I will take A. So I'll do the same thing again. I think we can write it in better way because I'm doing the same thing inside. But let it be. It's already very confusing, so let's not make it more confusing. This is done. Now I have a priority queue with the answers that I need. But it is in the reverse order because I have taken the max heap and the min heap where I needed a min heap and a max heap respectively, right? I've taken the opposite thing. So I have the right answers but in the reverse order. So I'll reverse it for my answer. So I'll take that in the answer and I will take that in the answer first. pq.empty, pq.top, answer.push, back, pq.top dot first, sorry, second, not first. And I'll remove it from the priority key. I'll reverse it, return the answer. So that's it. It's a very long code to implement, and yeah, let's see if it works. Save it. So I am printing param1. Param1 is the input, or param1 is the answer for the input I. So let's see. Okay. So I have not even used times. Instead of adding it one by one, I'll use times here. I see the problem. Uh, Here in search, when I am traversing, I want to go to that child only if it's present, not if it's absent. If it's absent, then I will return the empty string. Alright, so I see another problem. The problem is I'm traversing all the alphabets, but I forgot about the spaces as well. Space is also there, right? So instead of traversing through all the alphabets, I'll just traverse through through the loop, I mean through the map. So auto title uh, the map is root children dot this is the map dot begin and IT not equal to the same thing. Probably I've done the mistake of taking this variable in too long because it's frequently required, right? And this will be IT plus plus. Now I'll just uh, create a variable try new try and this will be IT uh, second and and new frequency. This will be IT first and instead of passing this, I'll pass IT first will be character. This will be character ch and I'll pass the ch here. I pass the ch here. I pass the ch here. Now this will also accommodate for spaces. I hope this works now. Let's see. It does. So I love you, Island, and I love Meatcoat are the maximum ones with the frequency 5, 3, and 2 because among these two will the space will be the lesser ASCII value. So this will be taken. The next thing is let me print the param 2. So this will be space. So only the spaces one will come up. So the only two things should come up. I love you and I love you. That's right. And in the order that it has come up. And param 3 will be I space A. That will be what? Nothing. Right? That's nothing. I will also test for the hashtag. So now if I have something called a hash in between, so I have this string and then hash. So I space A is going to insert, it's going to be inserted into the frequency and into the try map. And the next time I search for this, I should get a I space A, right? So if I do a param, let me just change it to param 4, param 6, and param 6 will be I space A. First I'll show you param. Now this is param 0, 3. Param 2 will be empty and param 6 will not be empty. Let's see. Param 2 we have already done. Param 6, let's see. This will come as I space A. Yeah, that's right. That's how we solve this question. Probably there might be other ways to solve it, easier ways, but I wanted to learn try, a practice try. It's pretty good practice for the problem. And thank you guys.